For F13, same thing. We draw the component, and we're going to calculate the component later. And this is F13, and 60 degree. And the same, we draw the components. Okay, this is Fx, Fy. This is a different Fx and Fy. Our Fx is F13 cosine 60, which is also 48.3 cosine 60. So we're going to see that this one is going to be the same, 24.2, except that this one is pointing to the left hand side, so you have a negative I. Okay, negative I for the first one. And then your Fy will be the magnitude and sine 60. Also 48.3 and sine 60. So this one is also 41.8, but also pointing up, so positive J Newton. So our F13 is negative 24.2 I plus 41.8 J Newton. That is our component for F13. Next one. Okay. Our next one will be F21. F21. So F21 is below the horizontal line, and we do the same thing for our F31 also. Okay, our F31. So this is our 21, and this is our 31. Okay, this is our 31. Right. That is the F31. This is the F21. So we can split them into components. Same thing. Fx, Fy, Fy, Fx, angle the same, 60 degree and 60 degree. Okay. So our Fx is the magnitude of 21 and cosine 60. Magnitude also the same, 48.3 cosine 60. So we're going to have 24.2 Newton, but pointing to the left, negative I. And then Fy, F21 sine 60, 48.3 sine 60, same, 41.8, except this one downward, so negative J Newton. So that means our F21 is equal to negative 24.2 I minus 41.8 J. Okay, and the last one will be F31. The Fx is the magnitude of 31 cosine 60, 48.3 cosine 60, 24.2 I positive Newton, and your Fy is this. That will be 48.3 sine 60, 41.8 Newton, but pointing downward, negative J. So finally we have the last difficult vector, which is 24.2 I minus 41.8 J Newton. Okay, all four of them. But we still have two more, which is this one. Okay, our last two will be the F23. F23 pointing to the left, so negative 48.3 I Newton, and the F32 is positive 48.3 I Newton. Alright, so then we calculate the net force on all of them. Okay, the net force on all of them, you need to sum up the vectors. The net force on Q1 is 1, 2, and 1, 3. 1, 2 plus 1, 3. 1, 2 is here, and this is 1, 3. Okay, 1, 2, and 1, 3. These two disappear. Only this one available. So that will be 83.6 J Newton. 83.6. Okay, correct, right? 83.6. Okay, next one is the net force on Q2. Okay, so that net force on Q2 will be here. That is F21 plus F23. 21 and 23. This is 21 and 23 is here. So 21, 23. You have I, 2 i's. If you sum up the I, both are negative, that will become negative 72.5. Okay, 72.5. So you have negative 72.5 I and minus 41.8 J newtons. That is a net force on Q2. And then for the Q3, okay, for the Q3 is F31 plus F32. Your F31 is here and your 32 is this one. So the I with the I, you get the same value, which is 72.5 I, and the last one also the same, minus 41.8 J Newton. Okay, so that is the net forces on Q1, 2, 3. But we not yet finished yet, because we still need to find the magnitude and direction. Okay, that is normally the part 5. Okay, the 5th part of the question here. These are difficult questions, so we need to rub this one off. Okay. Now, how can we do that? First, we draw the vector. For the first one, the net force on Q1 is 83.6 J Newton. This one no problem, because you only have one component. 83.6, no problem. We know that the magnitude is 83.6 Newton. One component, straight away that's the value. Direction is positive J. Okay, positive J. So that is the answer for the first one. And then for the next one is our net force on Q2, which is negative 72.5 I minus 41.8 J. You need to draw this component. Okay, we draw component number 1, negative 72, pointing to your left. Negative 72.5 I, and then you have here negative 41.8 J. Shorter because the number is smaller. And then when we combine both of them, you're going to get this. This is the net force on Q2. Okay, to get the magnitude on Q2, you need to use Pythagoras theorem. Okay, so let's find out what's the value here. 72.5 squared plus 41.8 squared, and square root everything. So we have 83.7 Newton. Okay, 83.7 Newton, and we need one more thing, direction. We call this one alpha. Okay, we use tangent. Tangent alpha is equal to negative 41.8 divided by negative 72.5. So your alpha is tangent 41.8 divided by 72.5. Well, 30 degrees. Okay, 30 degrees. So that is magnitude and direction. And the last one is the net force on Q3, which is 72.5 I minus 41.8 J Newton. Do the same thing. We draw this component, positive I to your right hand side, and then minus 41.8 J downward, same like this one. And then we calculate the magnitude using Pythagoras theorem. Okay, and that is the net force on Q3. Magnitude on the net force on Q3, same thing, Pythagoras theorem, 72.5 square plus negative 41.8 square. It seems the answer will be the same, 83.7 Newton. And the angle, we call this one theta, so tangent theta is equal to negative 41.8 over 72.5, answer should be negative 30 degree. Okay, negative 30 degree means you measure the angle in this direction, below the horizontal line, but clockwise. This one you measure from here, this one is anti-clockwise, positive, right hand rule. Point out, point in. Okay, so that's the answer for the last part for question number 11. Alright, that's all for all the tutorial discussion. Make sure you read all, watch all the video. Okay, and today's password is ethanol. Okay, remember, for attendance. So your next video will be on electric field. Okay, so wait for my update. Thank you.